was hoping that buzzing would stop when I turned those lights off, but no. Dadgummit.
Got water somewhere in the system.
So if I have this function here,
Good.
Sure. Okay. So it meets the two conditions. I didn't ask that as part of the question, but it does. It's continuous and differentiable because it's polynomial. Polynomial functions kick ass. So there's two initial things I have to do to set up my equation. One of them is find the derivative. And the other one is, so let me find my points. What are these? What is that? Those are my x values from x equal 1 to x equal 5. So I already know the x pieces of the points. If I plug a 1 in, why did I pick 5? I don't know. If I plug a 1 in, I get -1. If I plug a 5 in, I get 71. Yeah, like you would, Jeff. Are you guys with me? Those are my endpoints, correct? I know the interval over which I'm interested in. Therefore, I know the two inputs to get my endpoints. How do I get the y pieces of any point? Plug the damn things in. So I know I'm going to plug a 1 in and a 5 in. How do I get the slope between those 2 points? Now we're back in algebra. Yeah, it'd be 71 minus -1. Yes? Y2 minus y1 over 5 minus 1. 72 divided by 4 is 18. Kick ass. So then I take my slope and I set it equal to the slope I want it to be. Somebody really tell me specifically, what is 6x? What does it tell me about f? What is 6x? Tell me about f. No, 6x. What does it tell me about f? What is the point of f prime equals 6x? What's its job? Doesn't pass the butter. It tells me the slope at any point, at any x value of the, right? Okay, so that is every slope for f. You just put in a particular x value, it tells you where you are in the roller coaster ride, that is f. You guys with me? I want it to specifically be 18. Where did 18 come from? Well, that's the straight line slope, yes? I want this to specifically have a slope of 18. So then I take my function that represents the slope everywhere and I force it to be 18. And what do I get?
3.
Now, to be honest, I wish I could take credit for this coming out so clean. I just got lucky. I just made the ship out of nowhere and I'm like, holy shit, this is gonna work nice. I think most of you guys got it. Maybe at the worst you got like a half or something. Nothing too freaky. But if you get 11 over 17, who gives a shit? You're done. Right? What is it about that 3? What's the deal there? What's special about 3? Is it in my interval?
Yes.
Yes, thank the gods. We're guaranteed to have a value in the interval that has the same slope, because that's the whole point of the mean value. You guys kind of with me? So what is special about 3? It's where the function has the same slope as the crow flies. Yes. You guys with me? And I think last time I told you about, I could see and there it is again, my car is out that way. Way out there. Yes? And if I wanted to go in a straight line, I could get there, and there's a certain slope to that. If I'm looking up from above, you with me? I'm going to have to walk like this, because they don't want to climb up those rocks. Right? What a horrible headline. Bath boy found with his head cracked open with a bunch of rocks. Why the hell did he just walk around it? You guys kind of with me? So at some point, I'm going to be walking parallel to the way I would have been walking. I've got to go deviate away from the path, and then I kind of come back. You guys kind of with me? So this actually has real life applications, right? Although this is mostly used to prove other theorems. I desperately need you to understand this is so straightforward. How do I find where something is horizontal? Take its derivative, make it 0. I'm forcing it to be 0, and then I can solve for the locations where that happens. This is exactly the same thing. It's just a little more technical. It doesn't say 0. It just says, can you make it the same slope as if you had gone straight? That's all this says. So figure out what that slope would have been. Set your derivative equal to it. That's it. That's mean value theorem. Commit. Now you can talk about neat problems. I can't remember if I assigned the problem about the people running. I can't remember. Normally I like that one. No, that sucked. Too bad for me. So you can talk about mean value theorem in terms of if you have somebody run like this and you have somebody run like that, where they both running at the same speed at some point or so on. So there are more conceptual questions you could build on, but they all come back to this. There's got to be a point somewhere where they're parallel. Okay. Is that okay? And you got to stop looking at this. Now listen, it's fine if you look at this as just a procedure, but it's so much easier if you understand the idea behind the procedure. I hate memorizing shit. I just try to see why does some procedure make sense, and then I let it make sense. And then I'm not memorizing anything, I'm just doing what makes sense in the moment. You don't have to memorize, don't put your hand on the stove. Put your hand on the stove once, you're gonna remember that shit. What was I supposed to remember? Oh shit! Okay, sorry. Don't put your hand on the stove, please. Anything else from the quiz? So the only other thing I asked about was the absolute max and min. No, what was the other one? I forgot already. Huh? Oh yeah, just the critical numbers, that's right. Thanks, man. If you don't, well, alright, do you understand critical numbers are kind of a big idea? I mean, the word critical in there makes sense. Why do we call them critical numbers? Why are they so critical?
Whether it's 0.
That's where what might happen. That's where what might happen. Critical numbers are where what might happen.
The slope changes.
Yeah, a max or a min. Yes. And if I'm talking about the profit of a company, which is the standard boring ass thing, I want to get to the critical value, don't I? Because the critical number there would be the highest profit. Not this one. This one. Not this one. This one. You with me? You guys with me? So this has automatic applications in every field, everywhere in the known universe. You guys, finding the maxes and mins, those are very often key places. There's where interesting things happen. Are they always the only places? No, but it's good to have a method that helps me find those locations. Yes? Okay. So critical numbers specifically are where f prime is what?
0.
F prime is 0 or f prime is undefined. Right? And I should have been more specific on there. I should have said explain where it's coming from, and hopefully I didn't get that out of your work. And I haven't made all of these yet. We should have gotten several. Some that I made a 0, some make it undefined. So hopefully you guys notice that. We'll see. Okay. Anything else for the quiz before I move on? Okay. All right. Unless there's questions, there's one thing I want to do that I kind of skipped. And then I want to focus the entire time mostly on section 4.7, which is the next round of calculus word problems. Right. I've got 2 more workshops, but to be honest, you're going to get from me the same handouts I give for that. It kind of makes sense. I'm not going to hold those from you. No. I'm going to give you the same handouts. I am going to do some different examples though, just in case you want to come. So we do different examples there. You guys kind of with me? So going to the workshop's not required. Some of you guys have been. You don't have to go. You're fine. I understand not having time outside of class. I can't make it mandatory or anything. We'll give extra credit if you go, but if you don't have time and you want extra credit, just ask me. Figure something out. So there's one idea that I skipped, which I am really amazed that I skipped, because it's one of my favorite little things. Remind me what F double prime tells me about F. Okay.
It's the
Yes? Sorry?
speed or the
Yeah.
of change.
Right. Corey's like, I like your little one-word thing. It's the rate at which the first derivative changes. I love it. Because if I take the derivative of anything, that tells me the rate at which that changes. What I just said sounds really simple, correct? You all agree with me that a derivative tells you the rate of change of the thing, yes? If I take the derivative of g, I'll figure out the rate of change of g. You with me? If I take the derivative of f prime, I'm gonna figure out the rate of change of f prime. How quickly is my slope changing? So what's f double prime for a line? You don't need to do any calculus, do you? Is the slope changing on the line? No! So the second derivative is always 0, yes? You guys split, and of course it is, because it's x to the first. So one derivative, it'll be a number. Two derivatives, it's a 0. You guys see that? Okay. Stop for a minute. Okay, now, let's say I know that something is concave down. It could be like a parabola, yes? If I have a parabola opening down, then what's this gonna be? That's gonna be max, and that's gonna be where the slope is 0 in this case, yes? So this is such a beautiful idea, even if I have a more complicated function than just a parabola. If I find the critical numbers, let's say if C is a critical number for f of x. Let me do it like this, sorry, f prime. Because now we have critical numbers for f prime and critical numbers for f double prime. If C is a critical number for f prime, that means it's a possible location of what? It's a possible location for critical numbers are possible locations of local maxes, local mins, potentially absolute maxes and mins, yes, okay. If I do the second derivative and plug that in, and I get something that is less than 0, okay. Remind me, what's it mean if the second derivative is less than 0 at a point? It's concave, yeah, second derivative, yeah. Concave down. So that is a critical number I plugged in, and through it, it is concave down. So that has to be the location of a freaking max. That kicks so much ass. Do you understand? When this works, I don't have to make a sign diagram. What's the point of the sign diagram? If I have pluses and minuses, I know that's a max, right? It goes up to it, down from it, yes? If I just do the second derivative and plug the critical numbers in, I don't have to make the sign diagram, do I? Do you guys see that? If I plug it in and it's negative, that's a max. And if it's greater than 0, and why is this? Real quick, this is because, yeah, this would be opening down. This would be opening up, so it must be a min. These are local, by the way, local maxes and mins, because we're only looking at one point. I'm not comparing it to everything. Could be absolute, but I don't know if I only do this. Does that make sense? It's kind of beautiful. If I'm going through a critical number and my concavity is down, it's a frickin' max, because I'm gonna be like a down parabola for that moment. Now, what's the one situation I've left out? There's one situation I've left out. Yeah, if it equals 0, correct? And that's where shit goes to shit. And you're like, shit was already shit, Jeff. I know, but it's even more shit. If f double prime of C equals 0, no, then the answer can't be determined. We must make a sign diagram then. That kind of thing, yes? So that's the trade-off. If you plug in a critical number to the second derivative and it comes out 0, it's like, I don't know, man. Can you guys help me out? What's a cubic look like? X cubed. Yeah, okay. So right here, what's going on right there? It's 0, correct? The slope is 0, so that would be a critical number, correct? Right there, that would be a critical number. But is it a max or a min? Nope, neither one. It's just a temporary, you're climbing the mountain, you're like, holy shit, okay, let's go. You didn't turn, you're still going up, thank God, maybe later you'll fall. So watch, if we do a very simple little example, if I am given x cubed, what's the derivative?
3x squared.
There it is. And then the critical number would just be, you can see that on site, right? To make this 0, I make x 0, and it's never undefined. You guys see that? What's the second derivative?
6x.
If I plug this in, what do I get?
0.
I get 0. Indeterminate. It makes sense. If it was less than 0, it'd be a max. If it was greater than 0, it'd be a min. We already know going in it's neither, so of course it had to come out to 0. You guys follow? So if I have a more complicated function and I get a 0, I'm like, shit, alright, I gotta go back and do a sign diagram. That's the only way. So when second derivative test works, that's what this is called, the second derivative test. It kicks so much ass, because then you don't have to make the sign diagram. When else might you not want to do this? When would you not want to do this? If I'm only asking you for the local maxes and mins, when would you not want to use the second derivative test? You can do it. What do you have to find in order to use the second derivative test? Second derivative. So what if my function, first derivative already is disgusting as shit? It's some monster quotient with natural log of sine or whatever. Do you want to take another derivative? Alright, so there's a few things going on. If the second derivative is easy, I'm going to try this. Because even if I get a 0, I had a chance to not worry about the sign diagram. Are you guys all with me? The sign diagram is not that bad, but it can get a little detail heavy and I can make mistakes real easy. This is very straightforward. If this second derivative is difficult, maybe I'm not going to do it that way. I'm going to do the sign diagram. I'm okay with this right now, actually. We have a choice. Okay, I like it. Okay, maybe. So that is nifty. So instead of sign diagram, if the second derivative is relatively easy to get, I'll try second derivative test instead. Okay, maybe. So let's try another example. In this case, what's f prime? 3x squared minus 6x, good. Then I want to find the critical numbers, so what do? Is it equal to 0? Because I can see that it's never going to be undefined, right?
First you want to take out that 3.
Well, now I can factor this in, yes. So take out 3 and
X.
Good.
X minus 2.
So my critical numbers are
0
and 2. What's the second derivative? What's the second derivative?
6x minus 6.
Good. What's f double prime of 0? Alright, let me stop for a minute.
Negative 6.
Let me stop for a minute. Of course, this is an easy function, but the steps don't care. Steps don't lie. The steps don't care. So, if you plug a 0 in, what do you get? Negative 6. And what does that mean? It's going to be concave
Down.
down, and that means I'm going to have a
Max.
max where?
At 0. Negative 6.
Nope.
At 0.2?
Right now, what do I want to know? If you plug it into the second derivative,
Oh,
you're going to figure out its concavity. Is that what I want to know right now?
Yeah, plug it
No.
back in.
All already figured out its concavity. Its concavity is negative. I want to know where this point is and which function f prime, or f double prime does that. Which function tells me where
The original.
it is. The original, yes? F prime tells me how it's moving, and f double prime tells me with what style it's moving. Wow. You're going up, but you're going like this, not like that, right? So f double prime is a little, how you move. Is that okay? So when I ask you, where is this, or what is the full point, what is whatever, you have to plug it back into the original. And that would be 0, 2, yes. What's f double prime of the other critical number? Yeah, 12 minus 6 is positive 6, that means it opens up, it's concave up, so that means I have a min at 2, -2, yes. Good. How do you guys feel about that? That's actually really kind of nifty. That is a alternative to the what's called the first derivative test, which is the sign diagram, right? The bad part is sometimes the answer might be, I don't know, and then you have to go back and do the sign diagram anyway. Or the second derivative really sucks, in which case I might not even try this. I might just go ahead and do a sign diagram. Yeah.
This is just called like the second derivative test.
This is called the second derivative test. Yes. And its job is to determine local maxes and mins. In some cases, it can't tell. Situations where it's like, I'm a critical number, but nothing happens in, so shit. Yeah, maybe. Now, if I get a 0 here, does that mean it's not a max or a min? No, it just means it can't tell. You guys with me? Very quick example. Does this function have a minimum? What's it look like? X to the 4th looks like what? Parabola. Does it have a minimum? Yes, we call it the vertex. It's sitting on his bum, and a little 0, 0 is just sitting there, right? Derivative's easy. Yes, what's the first derivative?
Towards
No way. Critical number is x equals 0. Second derivative is 12x squared. When I plug in a 0, I get 0. So be careful. Don't assume when I get a 0, that means there's nothing. That means, no. It means it literally has no idea. It could or it couldn't, I don't know. So then we have to go back and do a sign diagram. That's two trade-offs. Second derivative might suck. Or even if it doesn't, I might get a 0, which means I have to go back and do the sign diagram anyway. But if the second derivative is easy as shit, I'm gonna do this. It's real quick and I have a chance to not have to make a sign diagram. Okay, maybe. Such a beautiful little idea. It's like if I have a critical number, I'm going through it like this, it's gotta be maximum. So, last time I kind of gave us a concrete example of what we're about to get into. We talked about rectangles with various side lengths and trying to make the area the biggest. It kind of makes sense that long and skinny is not a good way to set up a garden. You're going to use a lot of fencing to get nowhere near as much area. Yes? You guys kind of and if you go the other way and make it long and skinny this way, that also sucks. So it kind of makes sense that the best thing is right in the middle, which is make a square. So if you ever have a four-sided figure and you want to maximize the area, you make it a square. You guys with me? Now, what if I just wanted to maximize the area and I have my fence and I could put it any way I want to? Do you guys know how I would set that up? have to make a square or a four-sided figure, how would I maximize the area? Circle. We talked about silos last time, right? Fill it with peanuts or whatever. Yes, I'm a Georgia boy, so pecans, peanuts, whatever. You guys at all with me? So we see circular decisions being made before the math, like I told you, because they just trial and error realized, oh, I can hold more shit in there, and then math came along and said, oh yeah, you're doing great.
Yeah, it's just that.
Huh?
Yeah, they're just like, oh, yeah, no, we know this.
Yeah.
Actually,
Good job, man.
The
Way to-
math checks out.
Way to catch up, man. Exactly. Now, let me give you the most basic kind of problem, which means you're not going to see a lot of them. Yeah, here we go. Can't remember if I assigned this or not. Ooh, this is interesting. Okay, so this formula, I'm not going to Google it, but supposedly this is the formula for the rate at which photosynthesis takes place, where I is the light intensity. Yes? I be light intensity. Do you see how they gave us the formula already constructed? What is the worst part about a word problem? Setting up the damn formula, yes? Do you guys remember this?
Yeah.
I'm hoping some of you guys have gone through word problems. It's really unfortunate that students just hate it so much, and I think part of it is because of the way we teach it. So many situations we give you. Literally, did I put it on our syllabus or whatever, the Sally said there's only in math can you buy 60 cantaloupes, and nobody wonders what the hell's wrong with you. It's one of my favorite little comics. You get these dumbass things, you're like, Jim bought 80 tubes of, what? 80 tubes of toothpaste. What's up with Jim? Is he alright? Does he think is he a bunker dude? Is he settling down? Is he trying to get those big buckets of food? Yes?
Honestly, I feel like the best way for that sort of thing would be to, like, if you're at, like, you know, like, it'd be nice if they made the word problems actually make sense. Like, I mean, you're going to do that kind of number for those kind of numbers. Like, you could have a small business making those kinds of orders or something.
Yeah.
Make, like, you could do the exact same thing. It would at least make more sense.
Now, for example, this problem, if I wanted to give you this on a test, I would actually research and make sure that that's close to real. Right now, I didn't. I'm sorry. But if we look that up, maybe it is actually close to a real function in the real world. There's a lot of these kind of functions everywhere that if you're in a certain field, you just know them. This might be true. I don't know. Maybe later I'll remember to look it up. So this is the rate at which photosynthesis occurs for a certain intensity of light. You guys with me? That's what that function is. P is the photosynthesis rate. I is the intensity of the light. So the question is, what is the question, Jeff? Probably maximize. Yeah, what would I have to be to maximize the photosynthesis? You guys kind of with me? Okay. So how would I do that? Yes, okay, so I need you to understand, the calculus in 4.7 is basic, meaning stuff we've already done. And I know some of you guys are still doing the homework. You're like, I'm still doing this shit, Jeff. But we know if the problem says maximize or minimize, I know I'm going to take a derivative. I know I'm going to find the critical numbers, and then I know I'm going to use secondary to test or whatever to see if it's a max or a min. You guys kind of with me? Because if I want to minimize cost and I work at this company and I get a critical number, I'm like, set the price of this cost, and then that maximizes cost. I'm like, oh shit, I forgot to check. You guys kind of with me? I want to make sure it's this and not this, or else it's, I might get fired. Okay. So what do I do? So I want to maximize photosynthesis rate. So take the derivative, yes? Now, real quick, I could just put P prime, but what am I taking the derivative with respect to? What am I allowing to change?
The intensity.
And can't you see like somebody in the back room growing whatever they're growing, and then change the intensity of the light, yes? To see what makes it grow. So maybe you change the intensity of light, give it a few days, see what, change it again, give it that would be the experimental approach. This would be a theoretical approach. Are you guys at all with me? So I'm taking the derivative of respect. What am I changing? What am I allowing to change?
Intensity.
The intensity. So I'm going to take the derivative with respect to intensity. So the great thing with these word problems is it's not related rates. Related rates was implicit. It was d by dt, yes? And every damn thing was a function of time, and time was in the background. I don't know if you guys are with me or not. So to me, that calculus was a little bit funkier. This is straightforward calculus. So a lot of the work for 4-7 is in setting up the equation. This problem, they gave us the equation. You shed a little, you're like, thank you, problem. And then you just attack it with calculus. So how do I do that guy's derivative? Yes, derivative of the top, right? Good old quotient rule, yes? Times the bottom, minus the top, times
2i plus
derivative of the bottom,
divided by bottom square.
divided by the bottom squared, Jeff. Squared, Jeff. There you go, buddy. You guys understand what's happening? So this is old school calculus stuff we've done before. You could get any freaking rule show up at all at any moment. Just depends on how the function gets put together. This is very obviously quotient rule, yes? If you really wanted to, you could force this guy up and make it to a -1 power, but you would quickly realize, like young Jeff finally did, oh, that kind of is silly.
I mean, it's helpful sometimes. But
Sometimes.
You know,
I'm with you on that. So now I just get all my like terms together. What is this going to be? 200i squared minus 100i all over stuff squared. I mean, now I'm kind of like, I don't care anymore. Now it's just algebra now. 100i minus 100i, that's gone, yes? 100i squared minus 200i squared is negative 100i squared. Plus 400 over shit squared. Now, can you guys see very quickly? Critical numbers. If I were you, I would just eliminate undefined, right? I would just look for undefined first always so I don't forget to do it. Does anything make this undefined? Can you guys see very quickly that no real number makes this undefined? What would this have to be to make it undefined? Oh, I see. No. The input would have to be imaginary. How do I know that shit? Can you factor this? No, I'm going to use quadratic. What's the most important part of quadratic if I don't care if it's imaginary? B squared minus 4ac. Where is b squared minus 4ac? It's inside the square root. So if it's negative, I don't have to worry about shit, do I? B squared, b is 1. B squared is 1 minus 4 times 4. 1 minus 16 is negative. Screw that. Nothing makes it undefined. You guys see what I'm saying? The only way to make the bottom 0 is to use imaginary numbers. Can I have an imaginary light intensity?
No.
no.
We'll say no.
Or no.
We can't. We can't. We'll do that. Yes. No, we can't. Okay. So what's the other way to get the critical number?
Numerator equals 0.
Yes. Numerator and 0. If I do this divide, can you guys see I'm going to get I squared equals 4? So then I is
2.
plus or minus 2.
There's no negative.
Good. Intensity can't be negative. That's what they want. Yeah, okay. And they give you the units. It's a little weird. In this case, it's thousands of foot candles. Don't think about that too much.
Because they did it by candlelight.
Yes, intensity deals with distance and brightness. So it's got, don't worry. Okay. You have things called foot pounds also. Especially if you use non-metric, things get really stupid. All I care about is this too. Alright, so that was easy. That was easy. Thank you, Jeff, for an easy problem. Yes? Do it again?
Wasn't the denominator?
I2 plus.
Yeah, this guy. I'm sorry. Is that cool? No. If you do the same thing, I don't give a shit. Yes? Why would I keep writing this guy, especially because he doesn't give me any information? I'm just lazy. So if you do that same thing and I take points off your lava picnic, make a note. Okay, so let's try a harder problem. Yes? So here's my plan for today. We're gonna look at this problem, then we're gonna take a break, and when you come back, I'm gonna have you guys work in groups on a problem. So what do you guys, take a look at this problem. This is number 14 and 4-7 if you have your book. Otherwise, just look at it. Now, this, to me, is an interesting problem, but it's also a stupid problem. What kind of weird neurosis does this farmer have where he has to have one side 3 times length? We just deal with it. That's this guy. Everybody knows this guy. He's the weirdest dude ever. He's got to have things at certain angles. You with me? He's just got that neurosis. Just leave him alone. This is the way he is. Yes? And whatever he's going to put in there can't go in water. You with me? You'll see I have an example like this on, but I try to make it make more sense, but I might fail a little bit on there. Whatever it is he's gonna put in there, he's gonna put little potbelly pigs that are made out of sugar. So if they go in the river, that's the end of them, and they learn pretty quickly. He puts one in there like, oh, I see. I'm not gonna go there. So he doesn't need fence there, you with me? So he's got 1,200 feet of fencing. What does the 1,200 feet of fencing need to go into? What does it need to go into making? It needs to make this length, yes? It needs to make this length, and it needs to make this length. Now, they gave us 2 of the 3 sides. What am I gonna call? You guys with me? Why, in the problem it says one side is 3 times longer than the other. You with me? So, but, isn't this side isn't this side variable? Okay, so what are you gonna call that side? A?
Well, we use that as a number as a letter. We use the letter as a variable sometimes.
Sure, we'll use A. Why not? Screw Y. Y gets overused.
I think
You're fine. It could get a little confusing because another thing in there is area. So let's use
we
it.
use a capital A for area.
True. Alright. So here's what's really cool. Most of the problems, a good 95% of them are gonna fall into this. Let me see if you guys can see this in this problem. They are gonna just tell us information. They're gonna just tell us something, and we know it. And we're like, thank you, problem, I know something. And then they're gonna ask us about something, and that's something we know very little about to begin with. So what do they just tell us that we physically know for damn sure? What's the only thing we know for certain? We know 1,200 feet of fencing. Don't tell me X and 3X, because I don't know what those are. I just know one's 3 times the other. I don't know that for certain, do I? 1,200 feet of fencing. I know that shit, don't I? Can you set up a formula related to what I want to set up here using 1,200 feet?
3x plus x plus a
Yes.
equals 1,200 feet.
Wait, should we calculate it like the length of
Do it again.
calculate area?
Not yet. Not yet, we aren't. Not yet.
Not yet. Like,
So, they tell me 1,200 feet of fencing. What geometrical idea is that related to? Perimeter. Work on one thing at a time. Now, listen, Ezekiel, you're right. Area is going to come into play. Not yet. So what is the formula for the perimeter of this thing?
3x
Yeah, 3x plus x
plus a.
plus a, and that has to be 1,200. I didn't say in there, but I always try to say, in my word problems, when I make one like this, I'd say, I want to use all the fence. Right? So when you see a problem like that, you have to assume they want to use all the fence. So where do you see that? 95% of the time, you're gonna be able to identify a thing they just tell me. Okay, let me focus on that, let me set up a formula for it. Then they're gonna have something they ask me about. What is it they ask me about? What geometrical idea do they ask me about? The area. So, what shape is this in? See if you guys are cool as trapezoid.
So it's gonna be like sines and cosines.
See if anybody, let me see, you guys, alright, I'm glad we're doing this problem, just to show you. Oh, sorry, ask me, area. Yes, tell me, perimeter, ask me, area. Does anyone remember the area formula for a trapezoid? What's a trapezoid look like? Doesn't it look, now this one's a little bit funky, I agree. But a trapezoid basically looks like a triangle that's been beheaded. Yes. What's the area formula for a triangle? 1/2 base times height, right? Half height base. No, sorry. Trapezoid, there are 2 bases. So this is a funky shaped trapezoid, but if I put it on its base, there. Trapezoid has 2 bases and a height. You with me? Why is this not the height? Because it's at a slant. It's not the real height. Yes? The height is straight up and down according to its bases. So the area of a trapezoid is 1/2 height times the sum of the bases. So it's almost the area of a triangle, it's just got 2 bases. So it has to include both of them. That's one way to remember it. If you want to see the reason, I can show you, but does that sound familiar to anybody? It's basically 1/2 h times b1 plus b2. So it's got 2 bases, so shove both of them in there. So, can you guys set up the formula for the area?
Yeah, but 1/2
1/2 a times?
times 4x.
Times 4x. Which is? Which is? 2xa or 2ax, sure. 2 axes. Gotta cut down the wood for the fence. Do we have a formula set up fully for what they tell me? Yes. Do we have a formula set up fully for what they ask me? Yes. Now, if you went to the workshop, I'm sorry, you're hearing a lot of these voices, which is good. The area formula. If I just showed you this area formula, doesn't it make you think you can make a and x whatever you want them to be? Do you see what I mean? It looks like I just made a 20 and x 4 billion if I wanted to, but can I do that?
No.
Are a and x related to each other somehow?
Yeah.
Oh, definitely.
If I make a something, x has to be a specific thing,
3
correct?
times or 4 times.
If I made a 400, what would x be? 200, yes. Because so whenever I make one thing something, the other one has to change, yes? They can't both be whatever they want to be. The second thing is, why would it suck to take a derivative of the area formula the way it is? How many variables are in there?
2.
2. And I don't want to do product rule with these 2 variables. No, thank you.
Yeah, we gotta turn a into a variable of x.
No, yeah, so, okay. Can you solve what they told me for one of the letters? Okay. In this problem, guys, in this physical situation, is this true? Yes. Is this true? Yes. They are both true at the same time. This is the idea of substitution.
Plug that.
If I solve this for A, what do I get? Solve for A.
200 minus 4x.
Yes, just subtract 4x from both sides. So now I know anywhere in this problem, if I see a little a, I can replace it with 1200 minus 4x. That's what it's got to be. Yes? So do I see a somewhere? Little a. I do. plug that in. I know that A is 1200 minus 4x. Now, this is beautiful, because I almost forgot about this. 95% of the problems, find what they tell you, set up its equation. Find what they ask you, set up its equation. Use what they tell you to help you with what they ask you. How many variables is the area a function of now? 1. Derivatives, good. It's even worse than I don't want to deal with 2 variables. It's worse than that. It's I can't, because they're not both allowed to be whatever they want to be. Now I've included the fact that together they have to make a total. It's in there. It's in the mix. So now if I take this guy's derivative, can I find its critical numbers? And then could I figure out if it's a max or a min? Because the answer is going to be what makes this biggest. Yes, he wants the biggest area for his little sugar potbelly pigs to roam. You with me?
Does it matter which one you solve for on the perimeter?
Oh, it doesn't. It doesn't. I love that question. Why do you think I chose to solve for it? Because if I solve for x, what am I going to introduce? A fraction. Now listen, if I forced you to, you should be able to do that shit. But look what I did. I don't want to do that. I love math. Fractions are kick-ass. I'm not going to do them if I don't have to, because it's one more place humans can make a mistake. But Paula, your bigger question is there a reason I pick one letter or the other? That's the only reason, really. Which one's easier to solve for? You could solve for either one. It doesn't change the math at all. If I solve for A, I'm going to figure out what x is. If I solve for x, I'm going to figure out what A is. But the minute I know one of them, I know the other one. So it doesn't matter who you find first. Good. So what do I do now? Yeah, so now it's like a photosynthesis problem. If they would have just given me this dumb equation, I would have done exactly what we did. That first problem, they gave us the photosynthesis rate equation. And then we just attacked it. We had to make it. Now the rest of this should be easy as shit. I gotta figure out this guy's max. We know how to do that. Derivative, 0 or undefined. Yes, so what's this guy's derivative?
2400.
Prime, yeah. 2400 minus 16x, and then that's never undefined, so I just set it equal to 0. And then I get, I believe it's 150.
Yes.
150 what? Feet. Good. Now how do I make sure that's a maximum? Second here. Or, let me see if you guys are cool with this. Or, it's a stupid parabola, yeah? Isn't that parabola opening down? Isn't the area formula a parabola? Isn't it opening down? So if you just went, oh, it's a down parabola, Jeff, it's a max here. Leave me alone. I'd be like, left alone. It's here for you. Yes? You don't always have to throw calculus at a problem. Or, like you said, if you don't realize that, what's the second derivative? Negative 16. Does it matter what I plug in? This is always, no matter what I plug into negative 16. If you make x 38 billion, what's a double prime? Negative 16. It don't give a shit what you make x, yes? So this is always concave. And we already knew that shit because it's a down parabola, yeah? You guys see that? Of course the math came out to be this, because for a down parabola, it is always concave down. Yes, it's the definition of concave down. It's the picture we make. So is that a max?
Yes.
Now, real quick, do you guys remember, does anyone remember, for a quadratic, what's the shortcut to find the vertex? Does anyone remember that? Negative b over 2a, does that sound familiar to anybody? A couple of you guys. All right. Very quickly, The way you learn this in pre-calculus, do you guys remember the crazy ass quadratic formula? Yes? Yes? This is very quick. Where is the vertex if I know two intercepts? It's always where? The vertex will always be where? Between them. What is the point of this? What to do? It finds the x-intercepts. You with me? What point, if I rewrite this a little bit, what value is in between the two intercepts? It's negative b over 2a plus this shit, negative b over 2a minus this shit. Isn't negative b over 2a always in the middle? So that's the way we had to explain it in pre-calculus. To find the x value of the vertex, you do negative b over 2a. So sure enough, what's a and b in this? What's a?
24.
No, negative 8. A is always the number that's in front of the
Oh,
x squared. This is just out of order. So a is negative 8, b is, so 2400, negative 2400 over twice negative 8 is 2400 divided by 16, isn't it? Yes? Is that 2400 divided by 16? Which is what we just did to get 150. So of course this is going to be 150, yes? So for parabolas, you do not need calculus because their maxes and mins will be their vertex, and we have a shortcut to get the vertex. Sorry if you never heard negative b over 2a. That's that. Real quick. And then we'll take a break. Sorry. Not 0 yet. Yeah. If I have this, I have just written every quadratic formula in existence. What's this derivative? What's the derivative of this? Don't overthink it. 2ax. How do I find its max or min? Set it equal to 0. And if you solve this, you get frickin' negative b over 2a, yes? Yes? That's why I wish more of you knew negative b over 2a, because that's neat. Calculus just goes, that's nice, pre-calculus. There, that's the easy shit. Okay. Now, you're not always going to be working with parabolic, with quadratic functions. You're not going to be able to do the vertex thing all the time. You got to do calculus. So, let's do this. Let's take a break. When you come back, I'll give you a few handouts. I'll have you guys work on a problem. I'll finally shut up. Come back at 25 past. When you get back, we'll do one problem and then we'll head out. Word problem more than once. Scan through a word problem for several things independent of each other. So for these problems, you scan through it. What do they tell me? Let me find it. Let me focus. Let me scan through it again. What are they asking me for? So I don't know if students sometimes feel like you're supposed to be able to read and get everything you need from it. That's insane. Or you think you're supposed to be able to get right to the formula. That's insane, right? Okay, maybe. Okay. Oh yeah, by the way, don't forget, did everybody, I sent an email out about the change in the test date. Yes. Did I include that? We talked about that last time, yes? So the test was supposed to be next Monday, it's now next Wednesday. So I'll have the practice test this Wednesday. What else is happening this Wednesday? Another quiz, yes? I'm not being facetious when I say this, but you're welcome. You want more grades. So I feel bad when I can't give you at least 2 quizzes before a test. Okay. Yes?
What were the names of the formulas?
Oh, yes. So the tell me is officially called the constraint. And the ask me is called the objective. But I don't want the words to get in the way of being able to construct the function. So to me, tell me, ask me is just more accessible, right? Doesn't matter what you call them. Okay, so let's do this. Let me give you a very useful handout. Would that be neat? It's got worked out examples. So if I were you, this would be really good to have sitting next to me while I'm doing section 4-7. If you were at the workshop, I'm sorry, I might have just given you something you already have. Now, Maya, we're gonna do that last problem about the pizza. That's what I did do. Huh? Today at 4:30. Like I said, we'll do some examples that I'll get to in here in the workshop if you want to go. Okay. So on this sheet, I've given you some concrete examples. Everybody got one of these here, right? With all the blue writing? Okay. So try to break it up for you, right? The idea they tell us, the idea they ask us. So the problem we just did, they gave us perimeter, they asked us about area. This time they gave us the area, and they asked us about the perimeter. And I walked through everything. I walked through setting up those equations, solving what they tell us to use in what they ask us. So the perimeter at first is the function of two variables, when it really is just the function of one, because if I change the width, I change the length. So I really want that to make sense. Why does it make sense the perimeter only needs me to know width? Because if I know the width, I then know the length. Yes, because the area is 25. If I know the width, I know the length. So then I'm able to get perimeter as a function of width, and then I can take its derivative. And then here's the second derivative test. Cool. It's only negative for negative values of width, and I can't have negative values of width, so it's always positive. So this is a min. So that would minimize the perimeter. Okay. This last thing is really important. You got to make sure, always go back to the question to make sure you actually got the answer to the question. In this case, the question was, where to go? Find the smallest perimeter. We found the width. I have to find the perimeter. Bam. And then I give you another one about a box. Square base, open top. So you'll see some of these in the homework. I will give you, well, okay. Yes, I will, sure. What the shit is this?
The surface.
Yeah,
area.
surface area. Where is this coming from? X squared. What is that in that
Two.
picture?
X.
That's the base. And it's an open top. So what do I have to construct? The bottom, and that's an area of x squared. And then every side has an area of what? xh. And there's 4 of them. There you go. 4 sides and a bottom. Yes? I take my 1,200 square centimeters of material and I construct 4 sides and a bottom. Okay, I like it. That's what they tell us. They ask us for the largest volume we can construct, and the volume for this is easy. All right, length, width, height, the 3 dimensions, multiply them together. And then I take, now look, would you want to solve for x? Think about it. Can you see if you want to solve for x, you got to subtract this, use quadratic formula? No. Wouldn't I much rather solve for h? Can you see, like I think Paula, you said this earlier, it doesn't matter. It doesn't mathematically matter which letter you solve for. It doesn't matter. But to us humans, I'm like, I'm going to solve for the one that's easier to solve for. I don't want to solve for x. Are you kidding me? Can you imagine setting up the quadratic for that? B would be 4h. Do you understand? No, I don't want to do that shit. I'd much rather solve for h. H is almost by itself already. Subtract x squared, divide by 4x. Kabam! I mean, so do you see the flow of this problem? They tell me something, I set its equation up. They ask me something, I set its equation up. I use what they tell me to help with what they ask me. I can take this h and I can shove it in there. Kabam! Well, this is where I simplified it. Yes? And then you take the derivative, get the critical numbers, get the second derivative, make sure that it does what you want it to. Are you guys at all with me? This problem wanted me to find, what is it, the maximum volume? Largest volume. So sure enough, my second derivative is negative at 20. When you plug a 20 in, that's negative, correct? Okay, so if it's negative, that must mean it's a maximum. So be careful. I need you to understand, is it possible you get more than one critical number at this step? Hell yeah, we've gotten more than one critical number in the past, haven't we? So you better plug each one into the second derivative and make sure you pick the one that does what it's supposed to do. If you're just trying to make the cost minimum, you get two critical numbers, and you're like, let me just choose this one. That could be the one that makes the cost the maximum, like I was saying earlier. You want to check and make sure it's the one that makes it the minimum. Maybe. Okay, so I want to review an idea we're going to need in a minute. For a specific problem on this worksheet that I'm going to give you here in a minute. Do you guys remember arc length? Does anyone remember arc length? What? Do you guys, does no one remember arc? Okay, I'll get over that. What part of this do you think is talking about the length of an arc? This is radius, correct? What's this symbol here mean? Theta, the angle, correct? So if you know, that's arc length. So this is the length of the arc. With me. So an arc in mathematics is part of a circle, some kind of a curved piece. Okay. So if I want to know, here's the really cool thing about this. If I want to know the length of this, I'm not going to do the whole thing. The formula for the arc length is just r times theta. And all right, let me just take a minute. Do you guys y'all know degrees? Does everyone know radians? All right. Somebody went like this. So I guess no. Do you guys know what a radian is? What is a radian? Pi is a certain number of radians. That's if you go halfway around a circle, you go to pi radians. But what is a radian?
Like the square root of 3 over 2?
It's a circle measurement from relation to where you're going to be at.
Yeah, this kicks so much ass. Real quick, how many degrees in a circle? 360. Why? Because we just chose it. We stole it from the Babylonians. We had a base 60 number system, and we liked it. We used it for our freaking time. 60 minutes in an hour, 60 seconds in a minute. 360, can you divide it in a lot of different ways? Yes, I need you to understand. It's completely made up. We could have made it 400. 400 is a nice number too, yeah? There could have been 400 degrees in the circle. There could have been 3 degrees in the circle. Do you guys start to understand what I'm saying? That is a choice we made. Nothing special about 360, nothing inherent to the circle. It actually is something. In almost all of mathematics, you're going to use radians. Why, Jeff? Why do you use those things? Because they're weird. No, because what a radian is, it's literally, if I took this radius and I took it, and I curved it, and then I shoved it back on the circle, yes? I take the radius, and I curve it, and then I take this and I shove it back on the circle. I have just gone through 1 radian. Do you guys understand? A radian is a physical measurement. A degree is made up bullshit. So if I have to use one or the other, I'm going to use radians almost always. When they're out in the wild, you have to use radians. Now what the hell do I mean by that? So this is 1 radian if this is an r length. If the arc length is r, It's 1 radian's worth of angle. How are we doing so far? So if I go 2, 3, I almost make it halfway. How short am I? 0.141596, blah, blah, blah. I'm short to make pi. Pi would be perfectly halfway. Let me stop for a minute. What's the area, what's the formula for the circumference of a circle?
Pi r squared. Pi r squared.
Pi r squared is the area.
2
2 pi r. No square. That's the area.
Pi r.
2 pi r. Yes? So how many radiuses are around this whole thing? How many radiuses? It tells you right here. Look, 2 pi radii. Yes? 2 pi radii. Sorry. I need you to get this. So how many radians are in a circle? Frickin' 2 pi of them. Whatever the radius is, how do I get around the circle? 2 pi times that. So how many radiuses could I lay down on this thing? 2 pi of them. In fact, what would halfway be? Pi, and that's why it's 3.14 blah 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 of the radii would get me halfway. Maybe. Has anyone ever heard this before? If you've learned about radians, I'm really hoping that you were told about this. That's such a cool idea. Any circle you give me, this tiny one, tiny one. If I take its radius and I curve it, I go through the exact same angle I did up there. That's why I can reference an angle using radian measure, because it grows as the circle does. So that angle doesn't change just because I made the radius bigger. It's the same angle. You guys follow it. I don't need to make shit up. Okay. Now, where was I before I went off on that tangent? Oh yeah, I remember. I don't know where I put it, but we'll start. Oh, it's right here. So this is literally, if I know, let me see if you guys are cool with this. Radians are a number of radiuses. Yes, radii. You with me? So if my circle is got a radius of 10, and my angle is, you could do it, Jeff. 1.2 radians. I really want this to make physical sense. If my circle has a radius of 10 and my angle is 1.2 radians. Now you guys understand, when you see radian, you just put number of radii, right? Number of radiuses. So I got 1.2 what's? Radiuses. How long is each radius? 10. So how far did I actually go? 12. 1.2 times 10. I went 1.2 radiuses, and how long is each one? 10. So I went 12, whatever the shit. Let's give it units, meters. So this would be 12 meters. So what did we just do? Didn't we just do the radian length, the radius length times theta to get the arc length? There, that's the formula. S equals r theta. That is the formula for how far on the circle you go, given an angle in radians and a radius measure. So obviously, if my circle got bigger, the theta wouldn't change, but the radius would change. Yes. So then, if let me see. If this got bigger, and my radius is now 20, let's see, it's 25. Yes. Same angle. You guys with me? How far would I go now? 25 times 1.2. 30. You guys with me? That physically makes sense. If I go further away from the center and then start walking in a circle, I'm going to go further just to get the same angle. This is why flat earthers love to say the earth is rotating at 1,000 miles an hour. Do you feel it? No, we're rotating as quickly as the hour hand on a clock. It's just that we're at the end of a very long radius. I don't know if you guys are with me at all. You agree there's a center of the earth? Yes? You can argue about what's there, what kind of monsters, whatever. Right? Okay. I'm hoping. I don't know. There's a radius to us on the surface. Would you agree that's a big damn radius? Yes? So if you multiply that shit, you get 1,000 whatever miles an hour. That's bullshit. We're going as fast as the hour hand. because that's what the hour hand measures, is how quickly the earth is turning. Are you guys at all with me? So that is how fast we're, no, we're not gonna feel that shit, I'm sorry, okay. Oh, I keep having to do that, because I know there's flat earthers out there, and it concerns me. Okay, here's a second thing. What if I wanted to know the area of this sector? Well, here's the cool thing. If I cut this out, this piece of pizza here, and I lay it down, what shape does it almost look like it makes?
Triangle.
Triangle, yes. Remind me, how long is this?
Radians.
R theta, yes? Okay. I'm gonna cut to the chase, you ready? If I pretend like this is a triangle, what would its area be? 1/2 base times height, yes? What's the base? R theta. What's the height? R. So 1/2 R squared theta. That is the formula. That is actually it. Now, I didn't just prove it, but this is my favorite way to kind of like construct it. It does work because the curve goes down and up at the ends. So those kind of average out. So it does sort of become a triangle. I don't know if you guys are with me or not. But does that sound familiar to anybody? S equals R theta for arc length. A equals 1/2 R squared theta for area of a sector. So if you want to know how much crust, that's R theta. If you want to know the area of your pizza slice, that's 1/2 R squared theta. So let me give you this, and then I think we're not going to be able to do too much with it, but I can at least give this to you. Some of you guys already have this. Somewhere. Here we go. Oh, you got it. You got one. Okay. So, yeah. If you look at this last one here. So this is that same guy that had to make a trapezoidal fencing next to a river. He's got these weird requirements. So he's only gonna eat slices of pizza that have a perimeter of 32 inches. Okay. You ever saw Monk? Maybe he's a cousin of Monk. Can you imagine, can you guys see what I'm saying? So have you ever had pizza that's like really, it cuts it, it's like it's really long this way and then really short this way? Or you've had those really long ones like that, yes? You guys see what I'm saying? So there are many different ways to draw a piece of pizza. There's many different ways to get 32-inch perimeter. Somewhere there's a sweet spot. We're trying to find the sweet spot. So he needs to have a perimeter of 32 inches, what diameter pizza, to get the largest slice, yes? So what is it they just tell me? And that's the, well, it's the perimeter, yes? So if I draw this piece of pizza, oh yeah, so we did this. If I draw this piece of pizza, how long are these? R, good. And how long is this? R theta. So what is the perimeter? 2R plus R theta, and that equals 32. So there's the formula for what they tell us. Now, I didn't use the word, and don't worry about it, we'll get to the end, but I want my slice to be the largest it could be. And what is that related to? Maximize what? Area. That would be the largest slice of pizza, correct? You guys with me? Okay, so you see how I didn't say the word area? You just have to stop and think, well, we'll make it the biggest, the area being the big, okay. So now all of my attention is focused on creating an area formula, yes? That's one thing I haven't said yet. If it said maximize the number of puppies I can feed, I want a formula that represents the number of puppies I can feed, because then I can attack it with calculus. If it said minimize the wear and tear on my shoe, I need a formula that represents the wear and tear on my shoe, and then I can attack it with calculus. Yes? If it said maximize the number of cookies I can make, I need a formula for the number of cookies I can make, and then I want to maximize. I can attack it with calculus. So all of my attention now is I need to construct an area formula. And of course, what would the area of this be? Yeah, so you, oh, I see what you did, okay. 1/2 r squared theta. This is what they asked us. So that's the function, sure, Jeff. That's the function I want to work with, because that's the one it tells me to maximize. So then what do I do? I've got what they tell us, I've got what they ask us. What do I do? What do I do? Yeah, what's the perimeter a function of? What variables are involved in the perimeter? R and theta. What variables are involved in the area? R and theta. So I could use what they tell us. Which variable would you like to solve for in the perimeter? And what they tell us. You could solve for R. Theta looks easier. To be honest, Paola, R is not that hard to solve for either. So let's do this. I need to get going to the Sicily and do some stuff. We'll do this problem next time. In the meantime, if you want to look at some of the other problems, you can look at them. What we're going to do on Wednesday, we got the quiz first, finish up 4.7, and then I might say a few things about 4.8. I think 4.8 is as far as we're going to make it for this next test. 4.9, to be honest, I almost always make 4.9 on the next test, and it makes perfect sense because it leads right into chapter 5, so it's actually pretty cool. All right, thanks guys.
My brain
is full.
No, it just doesn't work how I like it.
Oh. Wednesday, the day of the test. Neat. All right, so then we'll have to figure out sometime you can make that up. Yeah. Just email me and remind me to figure out. Okay.
On the test
Yep.
for I accidentally used moles them instead of human body.
Oh, they're the same thing, just
Kind of, they're like